FastPath Introduction and Performance Revolution. Welcome to Azure ExpressRoute FastPath, a revolutionary technology that transforms network performance by bypassing traditional gateway limitations. FastPath represents a fundamental shift in how ExpressRoute handles data plane traffic. Traditional ExpressRoute routes all traffic through the virtual network gateway, which creates a bottleneck and adds latency. The gateway processes every packet, applying routing decisions and security policies, but this processing overhead limits throughput and increases latency. FastPath eliminates this bottleneck by allowing compatible traffic to bypass the virtual network gateway entirely. Instead of routing through the gateway, FastPath creates direct paths between ExpressRoute circuits and virtual network resources, dramatically improving performance. The performance improvements are substantial. FastPath can deliver up to 10 times better throughput compared to standard ExpressRoute connections, while reducing latency by 40 to 60%. This makes FastPath essential for high-performance applications like databases, file shares, and real-time applications. FastPath is particularly valuable for scenarios requiring high bandwidth and low latency between on-premises and Azure resources. Applications that previously suffered from gateway bottlenecks can now achieve near-native performance over ExpressRoute connections. However, FastPath has specific requirements and limitations. It requires ultra-performance or ERGW3AZ gateway SCUS, works only with supported scenarios, and bypasses certain gateway features like network security groups and user-defined routes. Today we'll explore how to implement FastPath, understand its architecture, configure it properly, and monitor its performance to maximize your ExpressRoute investment. Understanding the architectural differences between traditional ExpressRoute and FastPath is crucial to appreciating the performance benefits and implementation considerations. In traditional ExpressRoute architecture, all traffic flows through the virtual network gateway. When data travels from on-premises to Azure VMs, it enters through ExpressRoute and is processed by the virtual network gateway. The gateway applies routing tables and security policies before forwarding the traffic to the destination versus M. This gateway processing includes route lookups, policy evaluation, packet inspection, and forwarding decisions. While necessary for many scenarios, this processing adds latency and limits throughput based on the gateway's computational capacity. FastPath architecture fundamentally changes this data flow. With FastPath enabled, the virtual network gateway still participates in the control plane for route learning and policy distribution, but the data plane bypasses the gateway entirely. In FastPath mode, traffic flows directly from ExpressRoute to Azure resources without gateway processing. The ExpressRoute edge devices learn routes from the gateway control plane but forward data packets directly to virtual network endpoints, eliminating gateway bottlenecks. This architecture delivers dramatic performance improvements. Throughput increases substantially because packets do not wait for gateway processing. Latency decreases because packets take shorter paths with fewer processing hubs. CPU utilization on gateways drops significantly, allowing them to handle more connections. However, this architectural change means that certain gateway-based features cannot be applied to FastPath traffic. Network security groups, user-defined routes, and some advanced routing features do not apply to FastPath flows because they require gateway processing. The key insight is that FastPath optimizes the data plane while maintaining the control plane functions that ensure proper routing and connectivity across your network topology. Prerequisites and requirements. FastPath has specific prerequisites that must be met before implementation. Understanding these requirements is essential for successful deployment planning. The most critical requirement is the Virtual Network Gateway SKU. FastPath only works with ultra-performance and ERGW3AZ SKUs. These high-performance gateways have the computational capacity to handle FastPath control plane operations while maintaining data plane bypass capabilities. Standard, high-performance, and other gateway SKUs cannot support FastPath functionality. If you are currently using lower-tier gateways, you will need to upgrade before enabling FastPath, which requires careful planning for the migration process. ExpressRoute circuit requirements include premium SKU circuits for cross-region connectivity and sufficient bandwidth to handle the increased throughput that FastPath enables. Your circuit must also have stable, properly configured BGP sessions. Supported scenarios are limited but cover the most common high-performance use cases. FastPath works with virtual machines, virtual machine scale sets, application gateways, and load balancers within the same VNet as the ExpressRoute gateway. Unsupported scenarios include private endpoints, which still require gateway processing for proper resolution. VNet to VNet traffic that crosses network boundaries, certain advanced networking features, and traffic requiring UDR processing cannot use FastPath. Network design considerations include ensuring that your VNet subnet design supports direct routing from ExpressRoute to target resources. Complex routing scenarios may not be compatible with FastPath's simplified data plane. Cost implications include higher gateway SKU costs offset by improved application performance and potentially reduced infrastructure requirements due to better resource utilization. Gateway SKU upgrade process. Upgrading to FastPath-compatible gateway SKUs requires careful planning and execution. Let me walk through the upgrade command and process in detail. The command AZ Network VNet Gateway Update modifies an existing virtual network gateway to support FastPath. We specify resource group FastPath RG to target our resource group and name ExpressRoute Gateway to identify the specific gateway we're upgrading. The SKU ERGW3AZ parameter upgrades the gateway to the ERGW3AZ SKU, which is one of two SKUs that support FastPath. The AZ suffix indicates availability zone support, providing additional resilience. The alternative SKU Ultra Performance also supports FastPath but doesn't include availability zone features. The no-wait parameter is important because gateway SKU upgrades can take 30 to 45 minutes to complete. Without this parameter, the command would block until the upgrade finishes. With no wait, the upgrade starts in the background, allowing you to monitor progress separately. During the upgrade process, ExpressRoute connectivity may experience brief interruptions as the gateway restarts with new capabilities. Plan this upgrade during maintenance windows to minimize business impact. The verification command AZ Network VNet Gateway Show checks the upgrade status. We use query SKU.name to extract just the SKU information and confirm the upgrade completed successfully. The output should show ERGW3AZ after successful completion. Gateway SKU upgrades are generally non-disruptive but can cause brief connectivity interruptions. Test thoroughly in non-production environments first and have rollback procedures ready in case of issues. Cost considerations are significant. ERGW3AZ and Ultra Performance SKUs are substantially more expensive than lower tiers, but the performance benefits often justify the increased cost for high-performance scenarios. FastPath Enablement Configuration. Enabling FastPath requires specific configuration on the ExpressRoute connection. Let me explain the enablement command and its parameters in detail. The command AZ Network VPN Connection Update modifies the ExpressRoute connection to enable FastPath. We specify resource group FastPath RG for our resource group, and name ExpressRoute connection to target the specific connection between our ExpressRoute circuit and virtual network gateway. The Enable FastPath True parameter is the key setting that activates FastPath functionality on this connection. This tells Azure to bypass the virtual network gateway for supported traffic flows, while maintaining gateway control plane functions. The ExpressRoute Gateway Bypass True parameter enables additional bypass functionality for certain traffic types. This works in conjunction with Enable FastPath to maximize performance benefits for compatible scenarios. After enabling FastPath, the verification command AZ Network VPN Connection Show confirms the configuration. We use query parameters to extract specific FastPath-related properties and ensure they are configured correctly. The expected output should show enable FastPath true and express route gateway bypass true, confirming that FastPath is active on this connection. If these values are false, FastPath is not enabled, and traffic will continue using traditional gateway routing. FastPath enablement is immediate once the command completes, but it may take a few minutes for all FastPath optimizations to become active as routing tables update and data plane paths establish. Monitor connection performance after enabling FastPath to confirm that traffic is using the optimized paths and achieving expected performance improvements. Not all traffic will automatically use FastPath. Only supported scenarios benefit from the bypass functionality. If you experience connectivity issues after enabling FastPath, you can quickly disable it by setting Enable FastPath false to revert to traditional gateway routing while investigating. Performance monitoring and validation. Monitoring FastPath performance is crucial for validating its benefits and ensuring optimal operation. Let me explain the monitoring commands and metrics in detail. The first command, AZ Monitor Metrics List, collects performance data from the virtual network gateway. We specify the full resource path to our gateway and request the P2S bandwidth and tunnel average bandwidth metrics to monitor bandwidth utilization patterns. The interval parameter, PT1M, collects metrics every minute for detailed performance tracking. The start time and end time parameters define the monitoring window. In this case, 1 hour of recent performance data. P2S bandwidth shows point-to-site bandwidth, while tunnel average bandwidth shows ExpressRoute tunnel bandwidth. With FastPath enabled, you should see reduced gateway bandwidth utilization as traffic bypasses the gateway. The second command monitors ExpressRoute circuit performance using the bits in per second and bits out per second metrics. These show actual data transfer rates on the ExpressRoute circuit, which should increase with FastPath as bottlenecks are eliminated. The Network Watcher command, AZ Network Watcher Test Connectivity, performs end-to-end connectivity testing. We specify source resource as an on-premises connected VM and dest address as an Azure VM IP address to test the complete FastPath data path. The dest port 443 parameter tests HTTPS connectivity, while protocol TCP specifies the protocol type. This test validates that FastPath is working correctly and provides latency measurements for performance validation. Expected improvements with FastPath include 40 to 60% latency reduction compared to traditional gateway routing, 5 to 10 times bandwidth improvement for high-throughput scenarios, reduced gateway CPU utilization allowing higher connection density, and improved application response times for database and file share scenarios. Set up automated monitoring and alerting to track FastPath performance over time and quickly identify any degradation or connectivity issues that might indicate FastPath problems. Troubleshooting FastPath issues. When FastPath is not performing as expected, systematic troubleshooting is essential. Let me explain the diagnostic commands and common issues in detail. The first command AZ Network VPN connection show verifies FastPath configuration status. We target our specific connection and query FastPath related properties to ensure they are properly configured. If Enable FastPath shows false, FastPath is not active despite your configuration attempts. The second command AZ Network VNet Gateway show checks the gateway SKU compatibility. We query the SKU name to confirm it is Ultra Performance or ERGW3AZ. If it shows a different SKU, FastPath cannot function and you need to upgrade the gateway first. The route table command AZ Network NIC show effective route table examines routing for specific virtual machines. We specify the NIC resource ID and output format to see how traffic is being routed. FastPath traffic should show direct routes rather than gateway-mediated routes. The NSG flow logs command AZ Network Watcher show security group view checks network security group configurations that might impact FastPath traffic. NSGs can block FastPath traffic even though it bypasses the gateway, so security group rules must allow the required traffic flows. Common issues include unsupported traffic types where certain scenarios do not work with FastPath regardless of configuration, private endpoints, complex routing scenarios, and traffic requiring user-defined routes cannot use FastPath optimization. Gateway SKU incompatibility is another frequent issue. Only ultra-performance and ERGW3AAZ SKUs support FastPath. Standard, high performance, and other SKUs cannot enable FastPath functionality regardless of configuration. Network security group blocking occurs when NSG rules prevent FastPath traffic even though it bypasses the gateway. FastPath traffic still respects NSG rules applied at the VM or subnet level. BGP routing issues can prevent FastPath from working correctly. Ensure that BGP sessions are stable and that route advertisements are working properly between on-premises and Azure. FastPath requires proper control plane operation even though it bypasses the data plane. FastPath with Global Reach integration. Combining FastPath with Global Reach creates powerful high-performance global connectivity. Let me explain the configuration and benefits of this integration in detail. The Global Reach Connection Command AZ Network Express Route Peering Connection establishes connectivity between ExpressRoute circuits. We specify the London circuit as the source, target the Azure private peering, and create a connection named London NYC FastPath Optimized. The address prefix 10.10.10.0/29 parameter defines the Global Reach Connection subnet. Authorization key provides the security token from the remote circuit, and peer circuit specifies the full resource ID of the target circuit. The route filter command AZ network route filter rule implements FastPath optimized routing. We create a filter named FastPath optimized routes with access allowed to permit high-performance traffic types and communities specifying the networks that should use FastPath optimization. The connection update command enables FastPath on the Global Reach connected circuit. We use enable FastPath true to activate FastPath for traffic flowing through the Global Reach connection, maximizing performance for inter-site connectivity. This integration provides several benefits. Global Reach handles site-to-site connectivity through Microsoft's backbone, while FastPath optimizes the Azure entry points for maximum performance. Traffic flows from on-premises locations through Global Reach to Azure regions, then uses FastPath for optimal performance to Azure resources. The combination is particularly powerful for global applications where data flows between multiple on-premises sites and Azure regions. Database replication, file synchronization, and real-time applications benefit from both Global Reach's direct connectivity and FastPath's performance optimization. Monitor both Global Reach latency between sites and FastPath performance within Azure regions to ensure optimal end-to-end performance. The combination can deliver near-native performance for global applications with proper configuration. Consider bandwidth planning carefully when combining these technologies, as FastPath can significantly increase utilization of Global Reach connections due to improved performance characteristics. FastPath security and compliance. FastPath security requires special consideration because it bypasses traditional gateway security controls. Let me explain the security configuration commands and compliance implications in detail. The Network Security Group command AZ Network NSG rule implements security controls that work with FastPath. We create resource group FastPath Security RG for security resources and NSG name FastPath NSG for the security group. The rule name allow FastPath traffic with priority 100 creates a high priority rule. The direction inbound specifies this controls incoming traffic. Access allow permits the traffic, and protocol TCP specifies the protocol type. The source address prefixes 10.1.0.0/16 parameter defines the source networks that should be allowed. Typically, these are your on-premises networks connected via express route. The destination port ranges 443 and 1433 allows HTTPS and SQL server traffic commonly used in FastPath scenarios. The monitoring command AZ monitor activity log alert sets up security monitoring for FastPath resources. We create name FastPath security alert to track configuration changes that might impact FastPath security. The condition category equals security parameter monitors security-related events, while action groups specifies who gets notified when security events occur related to FastPath resources. Security considerations for FastPath include network security groups being the primary security control, since FastPath bypasses the VNet gateway. Ensure NSG rules properly restrict FastPath traffic based on source networks, destination ports, and protocols. User-defined routes do not apply to FastPath traffic, so you cannot use UDRs to redirect FastPath traffic through security appliances. Plan security architecture accordingly, using NSGs and endpoint-level security instead of routing-based security. Compliance implications include audit logging requirements where FastPath bypasses some traditional logging points. Ensure you have adequate logging at the endpoint level to meet regulatory requirements for traffic monitoring and security auditing. Private endpoints do not support FastPath, so highly sensitive services requiring private endpoint protection will use traditional gateway routing regardless of FastPath configuration. Plan your architecture to accommodate both FastPath and traditional routing as needed. FastPath best practices and optimization. Maximizing FastPath performance requires following best practices and optimization techniques. Let me explain the optimization commands and recommendations in detail. The VM optimization command AZVM update configures Azure vMIS for optimal FastPath performance. We specify the resource group FastPath RG and the name HighPerf VM to target our high-performance virtual machine. The set hardware profile.vm size equals standard D64SV4 parameter upgrades to a high-performance VM size with sufficient network bandwidth to utilize FastPath benefits. Lower Tier 5 MIS may not have enough network capacity to benefit from FastPath optimization. The accelerated networking command AZ network NIC update enables SRIOV for enhanced network performance. We target the vMIS network interface and set accelerated networking to true to enable hardware-level network optimization that works synergistically with FastPath. The proximity placement group command AZPPG creates a placement group for optimal VM positioning. We specify the resource group FastPath RG, the name FastPath PPG, and the location East US to ensure vMIS are placed close together for minimal latency. The VM creation command with PPG FastPath PPG places new VMs in the proximity group, ensuring they are physically located close together in the data center for optimal FastPath performance between VM to VM communications. Best practices include right-sizing VM SKUs to match your performance requirements. Use D-Series, E-Series, or other high-performance VM families that can fully utilize FastPath bandwidth capabilities. Enable accelerated networking on all vMIS that will use FastPath connectivity. This SRIOV technology bypasses the hypervisor for network traffic, working perfectly with FastPath's gateway bypass to minimize latency. Optimize application configurations for high bandwidth, low latency connectivity. Database connection pooling, file transfer protocols, and application-level caching should be tuned to take advantage of FastPath performance improvements. Monitor and baseline performance before and after FastPath implementation to quantify improvements and identify any bottlenecks that might limit FastPath effectiveness. Regular performance testing ensures you are getting maximum value from your FastPath investment. Plan for growth by designing your FastPath implementation to scale with increasing traffic demands and expanding application requirements while maintaining optimal performance characteristics.